Hi, this is Mr. Roche. We are here with Robots and Circuits, and we are going to try to generate a song with Arduino using the Arduino tone generator. We're trying to do something a little bit more sophisticated, but it seemed like a good assignment would be to actually use the piezo sensor and a Arduino to generate some tones because it's an easy hookup. Okay, so let's try to do that. Let's see what we can do. All right, so first go into 123D circuits and make a new electronics lab. So here comes. Okay, so you get this. It's got this. It's called the unnamed circuit. They're all called the unnamed circuit. So it's crazy to do that. So what you want to do is you want to click on that. Like click up here and then rename this. Let's call it like um, song with Arduino tone um, function. Okay, something like that. Okay, and then if you click on this green piece, it'll take you back to your list of your kind of gallery of songs. And then what I want to do is I want to go and edit it. So it'll show up, and there you go. You get a large breadboard. I'm going to edit this, so we don't need such a large breadboard. Hit edit. Okay, I'm going to go to components, and I'm going to pull up a couple of components. Let's see, I'm going to need an Arduino Uno R3. I'll pull that up. There it is. Go back in here. Okay, I need a piezo sensor, okay, or a piezo buzzer. Either one. I'll just take the piezo sensor because it makes noise. That seems fine. Maybe we could try with a piezo buzzer later and see if it sounds better. And I'm going to take a small breadboard because I don't need such a big breadboard. So I'm going to put the breadboard in here. Okay. And then close off the components. I'm going to click on the big breadboard till it turns blue, and hit the little trash can. So I'll get rid of it. And then what you end up with is this. You got a Uno, and you have a breadboard and a piezo sensor. So it's pretty easy to do this. And we'll see what we can do with it. Okay, so I'm going to put the Arduino over here. I'm going to go like this to spin it around. So it looks upside down, but that makes sense. And then I'm going to stick the piezo sensor. I don't know, the piezo sensor can be like any place, like on the board. Just has to do this. This works like a little speaker. It also will pick up vibrations. Like there's a piezo sensor like in a microphone. So what it does is it catches vibrations and it outputs a kind of a signal. Okay. So what we want to do is we want to get it to, we just have to power it up. So you go power and ground here. Okay. It's got a positive and negative side. So let's use the positive side. Okay. And what we'll do is we'll hook the positive side down here to the positive rail. Okay, so I just drew a line, I just clicked on it. And I can color this, and let's color it like red since it's positive, okay? And then what we're going to do is we're going to put it in one of the pins here so that it gets a signal from the Arduino, okay? So I'm going to put it in pin 8. It doesn't have to be a PWM port. It just has to be in here. What I'm doing is I'm clicking and it kind of allows me to turn it. So then I go like this. I can line it up. I'm going to continue on with this. Let me see. That looks good. Looks real neat. Neat is good in electronics. I'm going to color this red. So that's my output, right? And then I'm going to go like this. I'm going to go to the black rail. And I'm going to color this black because this is my negative side. And then I just have to get this to ground, and I could take it all the way over here. Don't love that the wires cross, but I can deal. I'm going to go like this. Keep it going like this. And then I'm going to go right to here. So that's a little bit off, but you can kind of square them. Looks good. Looks good. And then I'm going to color this black to make sure that everybody knows that this is like the ground wire, okay? And that's kind of it, okay? Now, what we need to do is, so that gets the hookup. And I guess what we're going to eventually do is our hookup's going to go out, we're going to sort of outsource this to like a MIDI controller, but we're not quite there yet. And we want to be able to make sort of like keyboards and stuff like that. So, so what I want to do is just right now, just use the, let's use the piezo for this second right now. Okay, and let's just get it to play a song, so you can learn the tone generator. And I guess what I was thinking of doing was thinking of taking the sound, the ultrasound or ultrasonic sensors, and you can use them as sort of a way to make music. But let's use the piezo right now. Okay, so piezo. This is gonna be simple. Probably like hopefully you'll enjoy the way it sounds and stuff. But this is what it's gonna do. Okay, so piezo sensor. All right, so what we need to do is we're going to have to write some code for this, okay? So if I go like this, hit the code editor button, I get a kind of a sample Arduino code, okay? It wants to work with pin 13, which I'm going to erase in this case. And again, the basic things you get with Arduino are a setup function and a loop. The loop kind of keeps repeating. So what happens with Arduino is in the beginning, it goes here, okay, and it sets things up. It turns on pins, it does things like this, and then in the second part, it does like this little loop, okay. So so that's what it does, and we can do a couple different things here. Let's okay. So what we need to do is we're going to use something called tone, which comes on board in Arduino. Okay, let me see if I can find this. There's a tone function. Okay, so we're going to use this. Okay, this is like the same kind of thing. We're using a piezo, and basically what you need to do is define some notes for it. Okay, so I'm looking at the Physics of Music site. Okay. And they actually have like the frequency in hertz of some notes, okay? So for example, like A, like these are different octaves. So if you go A on the 4th octave on a piano, that goes at 440 hertz. So this note vibrates 440 times like a second, basically. Okay, and so on. So the lower notes actually vibrate less, which is something you might know from physics, but that's a good thing. Okay, so I'm going to make something called a define, which I can do in Arduino for a couple of notes. Okay, so let me go back over here. Okay, and what I want to do is, oops, there they are. I'm going to go in here and I'm going to do them here. I'm going to copy them from another example and I'll put them in here, okay? So hang on a sec. Great, so I'm back, okay? And what I'm going to do is I'm going to do these defines, okay? So you guys can, and what a define is something like, I'm defining a variable basically, and this is an integer, and it basically is this one number, and you can't change it. That's why it's like defined, okay? It's, as opposed to an int, okay? So these correspond to actual hertzes, in nature. Okay, so I have to get this defined. So I have to make these notes. These are going to be my song. Okay, now I'm going to plan out the notes of the song. Okay, I'll show you how to do that. Okay, I'm going to make my song by defining it as a bunch of these integers together. Okay, so we'll call it melody. Okay. And okay, now if I did this and said equals 5, then I'd have like a variable, right? If I want a whole bunch of notes together, I'm going to make this thing called an array, okay? So, okay, an array is just sort of a list, okay? and it has, you can put a bunch of things in here between these brackets, and it'll remember them. Okay. So what I'm going to do is I'm going to put a bunch of these notes in here. Okay. Okay. So here it comes. This is my notes. Okay. So you can have your own notes. You can copy anything you want. Okay. Or you can just copy this basically. Okay. And I can and what happens is my song here has 1, 2, 3, 4, 5, 6, 7, 8 notes. Okay. Now another thing about a note is you have to have like a duration for them. Okay. So you have to, like, there's like quarter notes and whole notes and stuff like that, and you want them to kind of play for different durations. That's how you make music. So I'm going to have this other thing called duration. Okay. And I'll make another list of durations that correspond to my notes. So I'm going to need 1, 2, 3, 4, 5, 6, 7, 8 durations. Okay. Okay. And like I guess to be more clear, it's like note duration. Okay. So, or like this, note duration. And we'll go in here, and so I'm going to use, okay, so this note is going to be a quarter note. This one's going to be an eighth. This note is going to be an eighth. And then you have a quarter, and everything else is a quarter here, okay? And so, okay. So then, now all you have to do is actually just play the song, okay? And you don't have to play the song again and again. You can just actually play it right in here, okay? And what I'm going to do is I'm going to take every note in the list and play it, okay, for as long as I'm supposed to play it. So what I'm going to do is I'm going to set up something called a for loop, okay? And a for loop looks like this, okay? So what happens is there's kind of 3 parts to a for loop, okay? So you're saying that this note, and what happens is when you have a list, I'm going to start at the current note. Let's return to the current note. The current note is going to start at 0, and on a list, the place in the beginning of the list is considered the 0th place. Okay, and I'm going to say while current note is less than 8, so it's going to go 0, 1, 2, 3, 4, 5, 6, 7. Okay, I'm going to say current note plus plus. Okay, and while that's happening, then whatever's going to happen inside this loop is gonna work. It's just gonna go again and again and again. Okay. So what I want to do is basically want to play the note and maybe rest a little bit and then play it again. So first what I'm going to do is I'm going to compute like a time for the note. Okay. So a quarter note has to be like a quarter of a second. Okay. And an eighth of a note has to be an eighth of a second. So this line does that. This one up here. This line. So it actually goes longer than a second. This is like a second. 1,000 is a second. So note duration is going to be this times the current note. So what happens is note durations, which is this, so it's going to find this, which is 4. So this is going to be 1,000 milliseconds divided by 4, which is 25 milliseconds. And then you ask it to play the tone on pin 8, and you're going to say melody for the current note, and then you're going to go for the note duration. So it's going to play this note. So let me upload this and see what happens here for this. It'll be weird, but it'll so just play it really fast, okay? Okay. But what we need to do is we need to play it for a little bit, and then we need to like kind of delay or wait while we get the sound. Okay, and I only got a couple of seconds left, so I'm going to do this quickly. So what I want to do is delay this a little bit. So what I have to do is I have to create some kind of integer that's going to like kind of make a pause for some amount of time. Okay, so I'm going to let the note go like for its time plus a little bit. That's what I'm saying. And then and then what I want to do is I kind of want to shut off the note.